All right, class, let's go ahead and solve some problems with equations with these rational expressions. It's all the same stuff we learned in the first class, only now we've got slightly messier looking equations. So we need to bring what we learned in the first couple of videos and apply it to an equation. So let's look at one equation like this: 1 over 2 minus x minus 2 over 3 equals 1/6. Okay, we can just solve this one pretty straight away. Let's go ahead and subtract 1/2 from both sides, which gives us negative x minus 2 rather, over 3 equals 1/6 minus 1/2. So we've got this right-hand side that we need to combine using lowest common denominator. Turns out that we can write 1/2 as 3 over 6, which just allows us to subtract these two fractions, and we get that 1/6 minus 1/2 is equal to minus 1/3. Okay, so that should be fairly straightforward. Let's plug that back into our equation, and we've got that negative x minus 2 over 3 equals negative 1/3. Got a negative sign on both sides, so we can just cancel those. Right? Another way you can see that is basically you can divide both sides by -1. So if I divide the left side by -1 and the right side by -1, the negative signs will cancel out. Okay, so that we can rewrite that like this. Now what we want to do is multiply both sides by 3. We've got a 3 in the denominator on the left-hand side. What we're trying to get at here is we want to get the x all by itself on one side of the equation and all the numbers on the other side of the equation. Okay, so we've got this 3 in the denominator on the left side. We want to get rid of that. So we're going to multiply both sides by 3, which gives us x minus 2 equals 1. We can add 2 to both sides to get the x equals 3. Okay, so very straightforward. This is about as simple as these rational expression equations get. They do get a little bit uglier, as we're going to see in our next example here. Okay, so here we've actually got our variable in the denominator, which makes it a little bit trickier. Okay, so first thing we want to do is, there's no real clear way to just get all the numbers on one side ahead of time. We can't just multiply by x's, so let's find a lowest common denominator and actually go ahead and add these two terms together. So we've got an x on one side and an x plus 5 on the other side. These two fractions, these two rational expressions have already been factored for us. They're in its lowest common form. So our lowest common denominator is x times x plus 5. Okay, so we can now rewrite this in terms of the lowest common denominator. The left-hand side is missing the x plus 5, so we multiply the top and the bottom by x plus 5. The second term is missing the x term, so we multiply the top and the bottom by x. And then we can just leave the 9 alone. We don't have to worry about the other side of the equation when we do this. Good, so we've rewritten this equation. Let's go ahead and put them all together. The x plus 5 times 100 gives us 100x plus 500. The second term gives us 100x, and that's all divided by a single common denominator, x times x plus 5, which is all equal to 9. Okay, good. Now we want to get this x times x plus 5 out of the denominator. We want to get everything up onto a single level, single playing field. So we're going to multiply both sides times x plus 5 to bring that up on top. Sorry, that's a little messy there. And that gives us, after we add the two 100x's together in the previous line, we get 200x plus 500 equals 9x times x plus 5. Now we want to get, again, we want to try to get all of the variables on one side all together. Well, first I just went ahead and expanded this 9x times x plus 5, gives us 9x squared plus 45x. Let's move on to a new page. Here's that equation just rewritten. And let's go ahead and move this stuff on the left-hand side over onto the right-hand side. When we start to see that we've got x squareds and x's combined in a single equation and it doesn't look like anything's going to go away, we're going to want to get it all together so that we can end up factoring our equation. That's probably where we're going to be headed. So let's move the 200x and the 500 over to the other side of the equation, such that we're left with this equation here. We've got now 0 equals, so it looks like we're getting ready to find our form where we can factor this. We can combine our like terms. We've got this negative 200x plus 45x, which gives us negative 100x. And now we can factor this. I know that's an ugly factor. You can play around and ultimately find that. There's other ways you could have gone about this. Maybe factoring wouldn't always be the easiest way to go about this. You could you could find these roots other ways, but I was able to find this one pretty okay. So when we have an equation like this, we've got 0 equals one term, like this 9x plus 25, all times x minus 20. In order for this equation to be true, this means that either one of these terms always has to be equal for this equation to be true. Okay? Hopefully that makes sense to you. This 9x plus 25 must equal 0, and, or rather I should say, or the other part, this x minus 20, can equal 0. If either one of those is equal to 0, then the whole equation is equal to 0, right? Because 0 times anything is equal to 0. Good, so we can set this 9x plus 25 equal to 0. Subtract 25 from both sides, and then divide it by 9. And we find that one solution is when x equals negative 25 over 9. Another answer to this is when x minus 20 equals 0, which gives us that when x equals 20, this equation is equal to 0. Okay, so we've got two solutions for this equation. So it's not always immediately obvious when you start off with a problem like this that you're going to end up with two solutions, but you should always be keeping your eye out for it. If you end up with that x squared term in there, you're going to always end up with two terms. Okay, so keep that in mind. Anytime you have an x squared term, you will have two solutions. Similarly, if you have an x cubed term, you'll always have three solutions. So your highest order tells you how many solutions you're going to have. Let's look at a final example. This one's going to be a little bit more tricky. Okay, so you've got 1 over x plus 1 over x minus 3 equals x minus 2 over x minus 3. Okay, there's different ways we can go about solving this equation. The way that I'm going to do it is I'm going to move this term on the right over to the left-hand side. It's already looking so ugly that I'm not seeing a clear way to multiply things away. So let's just go ahead and assume we're going to have to do like we did in the previous problem, where we're going to get all the stuff on the left-hand side or right-hand side and end up factoring it. That's probably what we're going to end up doing here. Okay, so now we've got these three rational expressions that are added and subtracted together. So we need to find a lowest common denominator. And in this case, our lowest common denominator is x times x minus 3. The two terms on the right have both an x minus 3 in them. Then we have the 1 over x, so our lowest common denominator is x times x minus 3. Now we'll put this in such that they all have the same lowest common denominator. You should be getting very familiar with this by now. And now I've added these, oops, sorry, that's too many steps there. So I added all those terms up, and let me hide some of this for a second. Oops. I'm sorry, technical difficulties. Well, we'll just go with this. Okay, so we've got, ignore the red writing for a second here. We've got this x minus 3 plus x minus x times x minus 2 all over our common denominator. What we want to do is get that x times x minus 3 out of the denominator. So we're going to just multiply both sides times x minus 3. Okay? Let's go to a new page and just look at what we've done again, or kind of continue it on from there. Okay, so we can simplify this now. It gives us 2x minus 3 minus x squared minus 2x, okay? Clean that up a little bit, and we get minus x squared plus 4x minus 3. Okay, so all I've done there is distributed that negative sign through the parentheses and added like terms. Okay, I don't like to have negative numbers or negative signs in front of my leading term, in front of my x squared. So I'm going to multiply both sides by -1. So you see I've just put a parentheses around the whole thing and a -1 out there. Instead of saying, oh, I'm multiplying the left and the right, this is just my cleaner notation for saying I'm multiplying both the left and the right-hand side by -1. And now we can rewrite that as x squared minus 4x plus 3 equals 0. So now we've gotten rid of that negative sign out front, which makes it easier to factor. So we can factor this pretty easy. We need something that multiplies, two numbers that multiply to positive 3 but add to -4. So it gives us x minus 3 times x minus 1. And again, this gives us two solutions. It tells us that one solution is when x minus 3 equals 0. So in other words, when x equals 3. And another solution when x minus 1 equals 0, or x equals 1. So we have two solutions here again. But wait! Let's recall the equation we started with when we first got everything into the lowest common denominator form. Okay? Notice that we have a denominator here that has an x times x minus 3. So there are some numbers that don't exist in this equation. Remember that make our equation irrational. We'll have a 1 over 0, or some number over 0, which we can't have. So let's find out. We can't allow the denominator to equal 0. Okay? So there's two numbers that do this. One is when x equals 0, and the other one is when x minus 3 equals 0, or x equals 3. So one of our solutions, x equals 3, is not an allowed solution. It's what we call an extraneous solution. Okay, so you always want to keep your eye out for these things when you end up multiplying variables out to 0. So we basically got rid of this x times x minus 3 term by multiplying both sides. And we ended up losing this information, or rather hiding it. So you always want to, when you do this, keep an eye out for those forbidden values and make sure that one of your solutions isn't this extraneous solution. Okay. We covered a lot this week. Good job. Hopefully you'll see that there's a lot of old stuff now being blended in with the new, and good work.